Number 1. The sequence of squares shown below follows in this pattern until there are no squares left. We've seen these squares before in lesson 1. Write an explicit formula for b sub n. B sub n, the number of blocks in the nth term, in simplest form. So, we start with 16 squares. Then I lose 2, so I'm down to 14. I lose another 2, so now I'm down to 12. We lost 2 more, so I'm down to 10, and then 8. So clearly this is an arithmetic sequence because we have a common difference of -2. Each time we lose 2 blocks, so our common difference is -2. Our first term is 16. I start with 16. So the formula is 16 minus 2 times n minus 1 equals, this isn't a formula, it's not an equation until I set it equal to something. Don't write a sub n. They said call the sequence b sub n. So this is the explicit formula for b sub n. But wait, there's more, because it said in simplest form. So guess what we get to do with this -2? We get to distribute it. So we get 16 minus 2n plus 2. So we get 18 minus 2n. So our real final answer is 18 minus 2n equals b sub n. So they called for the answer in simplest form. This is not simplest form because you can distribute. Most of the times we can leave our answer like that, but they said simplest form, so I wrote it in simplest form. For each sequence, state the first term. Okay, so we need the first term, the common difference, and the explicit formula for the nth term. So these are arithmetic sequences if they have a common difference. A common difference is the number that we're adding. So looking at this pattern here, the pattern appears to be add 7. So the first term is 15, a sub 1 is 15, our first term is 15. The common difference is 7, so the nth term is 15 plus 7 times n minus 1. This next sequence, well, clearly the first term is -6. The common difference, you might look at this for a little bit. It's not that obvious as the other one was. So you do the second term minus the first term, or the third term minus the second term. You see what's the nth term minus the one before it. So you pick a term and then subtract the one before it. That's why we call it the common difference. -25 plus 6 is better known as -19. So we have a common difference of -19 here. So the nth term is -6 plus negative, so minus 19 times n minus 1. Notice how it didn't ask for simplest form here, so I just left it in that form. I didn't distribute because that's a very acceptable answer. Number 3, consider an arithmetic sequence. I know my sequence is arithmetic, so I'm thinking of adding or subtracting. That pattern is in my head, where what this is trying to say is the third term is -10. So I have a sequence where the third term, a sub 3, is -10. What does this say here? This says a sub 5 is 14. So that means the fifth term is 14. That's the fourth term. There's the fifth term is 14. Write an explicit formula. Then find a sub 22. This is the 22nd term. So an arithmetic sequence means I add the same number each time. I have that common difference. So there's a common difference, and there's a common difference. But that jump is 12. Not 12, that jump is 24. So, two common differences, when I add two common differences, I end up getting 24. So my common difference is 12. That's what I want to box in. I don't care that 2d is 24. I care that the common difference is 12. So using that the common difference is 12, we can now fill in the blanks. We can now fill in the blanks and say -10 plus 12 is 2. 2 plus 12 is 14. If I go backwards, I subtract 12. So -10 minus 12 is -22. Minus another 12 is -34. So the nth term is -34 plus 12 times n minus 1. To find the 22nd term, I'm going to do negative 34 plus 12 times n minus 1. 22 minus 1 is 21. So you're going to pull up your handy-dandy calculator and figure out what is negative 34 plus 12 times 21. And get 252 minus 34 is 218. So if this pattern was to continue, in the 22nd slot, in the 22nd place would be 218. Number 4, the population of a town is measured each year and shown below. Would an arithmetic sequence be appropriate? So an arithmetic sequence is appropriate if I'm based on adding or subtracting the same number each time, that common difference, to model this data. So explain your reasoning. So how do I get from one term in the sequence to the next? So we start with 250,000 and we end up with 250,937. So that's clearly plus 937. To do the next hop, I'm going to use my calculator for this. 251.87, 251.87, 878, sorry, minus the second term, minus the term before it. 250,937. That was a change of 941. So it doesn't look arithmetic, but let's check the last jump. Let's check the jump from this term here. 252,822. 252,822 minus the term before it. 251,878. That was a change of 944. So, is an arithmetic sequence appropriate? No, because there is no common difference. There is no common difference. You don't add the same number each time. There is no common difference in this sequence because that went from 937 to plus 941 to plus 944, and this pattern would probably continue. So arithmetic sequences are all about adding and subtracting the common difference from the first term, and we end up with the explicit formula that's on our reference sheet. The nth term is given by, the nth term in any sequence is given by the first term plus d times n minus 1, where a sub 1 is your first term, d is your common difference. And we like explicit formulas because to find the 100th term, all we have to do is plug in 100 for n. That's what's nice about these explicit formulas for arithmetic sequences.